Imagine it's November 1918. World War I has just ended, but armies across Europe are facing a serious challenge. The battlefields are wrecked, muddy, cratered, impossible to cross with ordinary vehicles. Trucks kept getting stuck, tanks often broke down, and soldiers still had to move across ground that looked like it belonged on another planet. So the question was, how do you move troops and equipment across terrain like that? This is where the idea of the half-track comes in. Something that mixed two systems people thought wouldn't work together. But they had to. The concept actually goes back to 1915, when a French engineer named Kégresse was working in Russia for Tsar Nicholas II. The royal cars had trouble getting through the snowy terrain, so Kégresse replaced their back wheels with flexible rubber tracks while keeping the front wheels for steering. It was a simple, smart fix, and it worked. By 1919, French car maker Citroën bought Kégresse's idea and started building vehicles using his system. These early hybrids proved they could go where regular wheeled vehicles couldn't. At first, no one was thinking about war. It was just about traveling through rough ground. But that changed in the 1920s. Military planners started seeing gaps in their strategy. Tanks had power but moved incredibly slowly. The British Mark V, for example, barely hit 4 miles per hour. Trucks were faster, but couldn't handle rough terrain. Infantry was still walking, just like they had for centuries. That meant tanks would move ahead, then have to stop and wait for foot soldiers to catch up. Even though Germany lost a war, their engineers were already sketching new ideas. The Soviets were also testing new vehicle designs. In the U.S., the Army started working on concepts at Rock Island Arsenal. What made half-track so interesting was their mix of benefits. You got a lot of the off-road ability of a tank, maybe 70%, and about 80% of a truck's speed and simplicity. The front wheels made steering easier, and you didn't need the complex braking systems tanks use to turn. The tracks in the back helped spread weight across tough terrain like mud or snow. And since only the rear was tracked, the whole vehicle stayed lighter, cheaper, and easier to repair than a full tank. In 1931, the U.S. tested the Cunningham T1, which was basically a truck with tracks added to the back. It looked strange, but could cross trenches that would trap normal trucks. By the mid-1930s, things got serious. Germany was secretly rebuilding its military. Japan was moving into China using mechanized forces. The Spanish Civil War, 1936 to 1939, became a proving ground, showing just how important it was for infantry to move fast and arrive ready to fight, not worn out from a long march. At this point, half-tracks weren't just clever machines. They were essential. Engineers in the U.S., Germany, and the Soviet Union were all working on the same problem: how to build something that could move like a tank, carry like a truck, and support weapons like artillery without being too expensive to build in massive numbers. This question shaped the vehicles that rolled into Poland, France, North Africa, and beyond. In the U.S., the approach focused on large-scale production right from the start. While European engineers worked on custom solutions, American companies like White Motor Company in Cleveland and Autocar in Pennsylvania were designing vehicles that could be made by the thousands. Their answer: the M2 and M3 half-tracks. These look basic from the outside, but pack smart engineering under the hood. They use a Hercules JXD inline 6-cylinder gas engine, 386 cubic inches, putting out 147 horsepower at 2,800 revolutions per minute. That may not sound powerful today, but it was reliable, easy to build, and familiar to mechanics who already worked on civilian trucks. The engine sat up front, like a regular truck, which made repairs and cooling much easier. On roads, the M2 and M3 could reach up to 45 miles per hour. Off-road, they dropped to around 25 miles per hour depending on conditions. Still fast enough to keep up with tanks, but slow enough for soldiers riding in back to stay safe and comfortable. The transmission was where American engineers got creative. They built a 4-speed manual gearbox with a 2-speed transfer case. That gave drivers 8 forward gears and 2 reverse. This setup let the vehicle crawl up steep hills or cruise at decent speed on highways. Power went to both the front wheels and the rear tracks. The front wheels steered like a regular truck, but the driver could also use pedals to brake individual tracks, allowing tight turns, almost like spinning in place. It took practice, but trained drivers could maneuver with surprising precision. The track system itself was a smart American solution. Instead of metal links like on tanks, the M2 and M3 used rubber block tracks made by Firestone. These tracks had steel cables inside, covered in rubber, with 110 individual blocks. Each block was about 5 inches wide and designed to grip rough surfaces. This design had 3 big advantages. Rubber tracks were much quieter than metal ones, great for surprise movements. They lasted longer on paved roads. They didn't tear up roads or wear out quickly. Another big advantage of the American half-track design, if part of the track got damaged, you didn't need to replace the whole thing. You could just swap out individual rubber blocks right there in the field. Quick, easy, and efficient. The suspension system used a basic but effective setup. It relied on tall coil springs mounted vertically behind each of the 4 road wheels on each track. When the vehicle hit bumps or rough ground, those springs helped absorb the impact. Was the ride smooth? Not really. Riding in the back of an M3 over rough terrain felt rough and noisy, more like bouncing around inside a metal drum. But it worked. It was simple to fix, and it spread the vehicle's weight across a wide area. That mattered. The M3 weighed about 20,000 pounds in combat. Thanks to the track design, ground pressure was only about 10 pounds per square inch. For comparison, a fully loaded truck could reach 40 psi, which is why trucks often sank in mud while half-tracks kept rolling. Once the U.S. entered the war in December 1941, production exploded. White Motor, Autocar, and Diamond T were building 500 half-tracks per month by mid-1942, and that jumped to 1,500 per month by 1943. By the end of the war, over 41,000 had been made in various versions. This was the core strength of the American method. The half-tracks didn't need to be perfect. They just needed to be reliable, easy to build, and available in huge numbers when it mattered most. Meanwhile, German engineers were taking a completely different path. Instead of focusing on quantity, they aimed for technical precision, no matter how complex or expensive it got. Take the Sd.Kfz 251, also known as a Hanomag, built by Hanomag and other companies. While the U.S. focused on mass-producing solid, workable machines, German designers wanted every part to be top-tier, engineered to the extreme. The Sd.Kfz 251 ran on a Maybach HL42 6-cylinder gas engine that produced about 100 horsepower, less than the American Hercules engine. But Maybach also made engines for heavy tanks like the Panther and Tiger. So this wasn't a truck engine adapted for war. It was made specifically for military track vehicles, with strong low-end power for tough conditions. It could reach 53 kilometers per hour, about 33 miles per hour, on roads a little faster than the M3. Off-road, performance was similar to the American version, around 20 to 25 kilometers per hour. The Maybach engine ran cooler and used fuel more efficiently, but it needed more maintenance and had parts that were harder to make. The transmission system was another example of German over-engineering. The Sd.Kfz 251 used a Maybach Varirex 1 28H transmission with 7 forward gears and 3 reverse. That's right, 7 gears forward. The driver would choose the next gear with a lever, then tap the clutch, and the gear change would happen automatically through a vacuum-powered system. When it worked, it was smooth and fast, better than U.S. gearboxes. But when it broke, which happened often, it was a serious headache. Repairs required trained mechanics and hard-to-find parts that could take weeks to get. That pretty much sums up the German half-track story. Technically advanced, but tough to keep running. The track system told a similar story. Instead of using rubber blocks like the M3, the Hanomag used metal tracks, narrower versions of tank treads. Each side had 70 manganese steel links designed to grip rough ground. These lasted longer than rubber and were incredibly tough, but they were noisy, tore up roads, and needed constant maintenance to stay in shape. Germany accepted those problems because metal tracks performed better in extreme environments, deep mud, snow, or freezing cold where rubber could crack. But German engineers didn't stop there. One of their boldest choices was the interleaved road wheel system. Most half-tracks, including American ones, had 4 to 5 road wheels per side mounted on separate arms. But the Hanomag had 7 overlapping wheels per side, with each wheel weaving between the ones on the opposite side of the track. If you look from behind, it almost looked like the wheels crisscrossed. This design spread out the weight more evenly, lowered ground pressure even further, and gave a smoother ride than almost any other track vehicle. German soldiers who rode in both U.S. and German half-tracks said the Hanomag was much more comfortable. No contest. But there was a catch. This design was a maintenance nightmare. If a wheel deep in the middle broke, you had to take off several outer wheels just to get to it. And in cold climates like the Eastern Front, mud, snow, and ice would freeze solid between the wheels. Temperatures could drop below -40, and German crews often spent hours every morning just breaking their wheels free with hammers or torches. Something that might take 15 minutes on an American half-track could take half a day on a Hanomag. It wasn't just about the parts. It was about the labor, too. The Sd.Kfz 251 took around 3,000 hours of skilled work to build in 1940. By comparison, the M3 took about 800 hours. Germany made roughly 15,500 Hanomags during the entire war. That was impressive given their situation, but it was still only a third of what the U.S. built. In the end, it came down to quality versus quantity, and both sides showed the strengths and limits of their approach in steel and rubber. Then things got even more interesting. Someone had the idea, why not mount artillery directly onto these vehicles? It sounded odd at first, but there was a real problem with traditional artillery. It was usually pulled by trucks or even horses. That meant setting up took a long time, and once it was in place, moving it again to avoid enemy fire was tough or even impossible. Mounting a full-size gun onto a half-track suddenly gave armies something powerful. Mobile firepower that could shoot and move fast without falling apart. But pulling it off was anything but easy. First challenge? Recoil. A 75mm gun kicks back with around 15 tons of force in a split second. If you just bolted it onto a half-track's flatbed, that force would rip the frame apart or even flip the vehicle over. American engineers working on the M3 gun motor carriage in early 1941 came up with a smart fix. They mounted the gun, a French 75mm cannon, on a heavy-duty pedestal welded directly to the vehicle's frame, not just to the cargo body. Then they added big hydraulic cylinders that absorbed recoil. These allowed the barrel to slide back about 2 feet when fired, stretching that brutal kick into a more manageable push spread out over a second. But even with recoil control, the whole vehicle still rocked from each shot. So engineers added outriggers and spades, metal supports that dropped down from the sides and back to dig into the ground. These stabilizers anchored the vehicle before firing. Larger guns needed even more support. The M12 gun motor carriage, which carried a huge 155mm howitzer, had a massive spade at the rear that had to be jammed into the ground before every shot. Without it, firing would shove the entire 26-ton half-track backwards several feet. The Germans had their own version, the Sd.Kfz 251-9, which mounted a short-barrel 75mm gun in a fixed mount with limited side-to-side movement. Instead of trying to build long-range artillery, they focused on something closer to an assault gun, a vehicle that could drive up with infantry, take out a building or bunker, and move on. Because the gun couldn't swing far left or right, it reduced stress on the frame. But that also meant it wasn't for indirect fire. It was strictly direct fire at targets within about 800 meters. Then there was ammo storage, which quickly became a headache. Traditional artillery could keep shells nearby, protected and ready to reload. On a half-track, the shells had to travel with the gun crew inside the same vehicle. The M12 GMC could only hold 10 155mm shells inside. Each one weighed 95 pounds and took up a lot of room. So they typically had another vehicle, like an M30 cargo carrier, trailing behind with about 40 extra rounds. German models faced similar limits. The Sd.Kfz 251-9 carried 52 rounds of 75mm shells, stored along the thickest armored parts of the vehicle for protection. Then came the anti-aircraft versions, which pushed the limits even more. The M16 multiple gun motor carriage packed 4.50 caliber machine guns into a powered turret. It was a rolling flak cannon. But that whole turret setup, guns, electronics, and power system, weighed over a ton and sat high on the vehicle. To keep it stable during sharp turns, engineers had to widen the track base and add counterweights. The M16 could fire 2,400 rounds per minute in total. Sound impressive, until you realize that burns through 200 pounds of ammo per minute. The M16 carried 5,000 rounds total, which meant it could fire nonstop for about 2.5 minutes before it ran dry. Most of its interior space? Just crates of ammo belts. The Germans took the concept even further with the Sd.Kfz 251/22, introduced in 1944. It mounted the deadly 75mm Pak 40 anti-tank gun, which could punch through 100mm of armor from 1,000 meters out, strong enough to take out Soviet T-34s. But packing a gun that powerful onto a light chassis came with serious compromises. The vehicle could only carry 19 shells. The armor around a gun was thin because adding more would overload the suspension. And if the ground wasn't level, firing risked tipping the whole thing over. Crews had to pick their firing spots carefully, knowing their first shot might be the only one they got before they had to move or get hit in return. These half-track-based tank destroyers were often a mix of smart solutions and desperation. By 1942, both the Allies and Axis were facing tanks they hadn't fully prepared for. German Tiger tanks could shrug off most Allied guns. Soviet T-34s overwhelmed defenses with speed and numbers. Even lighter Japanese armor in the Pacific needed more firepower than rifles could deliver. The core problem? Building actual tanks was slow and expensive. Mounting an anti-tank gun on an existing half-track was something you could do in months, not years. The American M3 gun motor carriage was the first attempt. Built before Pearl Harbor, engineers at Aberdeen Proving Ground took basic M3 half-tracks, removed the rear seats, and bolted on a 75mm M1897 gun, a cannon dating back to World War I, right into the back. No turret, no real protection, just a steel gun shield. The 5-man crew stood fully exposed from the waist up, but it could knock out German Panzer III and early Panzer IV tanks from 1,000 yards away. Between 1941 and 1943, the U.S. built 2,202 cubic meters GMCs. They were first used in combat in North Africa, starting in November 1942. At battles like Kasserine Pass, U.S. forces quickly learned how tough German armor could be. The M3 showed the limits of the half-track tank destroyer. It could fire and destroy tanks, but it couldn't take a hit. The side armor was just over 6 millimeters thick, barely enough to stop small arms, and completely useless against anything heavier. German gunners quickly figured out that M3 gun motor carriages were top priority targets. Taking one out early removed a serious threat. American reports from the fighting near Sidi Bouzid in February 1943 showed that M3 crews had to stay hidden, fire from at least 1,200 yards away, and move constantly. They couldn't afford to be caught in the open. These vehicles weren't meant for head-on fights. They were hit-and-run ambushers. The Germans ended up building their own half-track-based tank destroyers out of sheer necessity, especially on the Eastern Front, where Soviet tanks were coming in massive numbers by late 1943. One early attempt was the Sd.Kfz 251-10, which mounted a 37mm Pak 36 gun. But it was outdated. It couldn't penetrate the front armor of a Soviet T-34. That pushed engineers to create something more powerful, the Sd.Kfz 251-22, which mounted a much stronger 75mm Pak 40, the same gun used in Germany's dedicated tank destroyers. Production started in 1944, and around 175 were built before the war ended. This setup could actually take on Soviet armor. The Pak 40 could pierce up to 133mm of armor at 500 meters using standard shells, enough to go through the T-34's hull or turret at typical battle ranges. But putting such a heavy gun on a light half-track brought major problems. The gun alone weighed over 3,100 pounds. Add the mount, shield, and shells, and you're pushing 2 tons, on a vehicle originally built to carry soldiers, not cannons. The Sd.Kfz 251-22 became front-heavy, hard to handle, and constantly pushed its suspension to the limit. Its top speed dropped to 40 km per hour, and off-road handling got noticeably worse. German crews said driving one when fully loaded was like trying to steer a stubborn animal. It took real effort, especially in mud or snow. By 1944, both U.S. and German tactics had evolved based on hard lessons. Half-track tank destroyers were best used in defensive positions, where they could hide, fire from long range, and relocate fast after shooting. During Operation Bag Ration, the massive Soviet offensive in June 1944, German 251-22s were used in small groups, usually 3 to 5 vehicles tucked into tree lines or behind terrain features. They'd wait until Soviet tanks were within about 800 meters, fire a quick volley, then fall back to another position. Survival meant staying mobile and never getting stuck in one spot. The Americans learned similar tactics in France after D-Day. In battles like the one around St. Lo in July 1944, M3 gun crews worked alongside M10 tank destroyers. The M3S would draw German tanks into the open, then the heavier M10S, built for the job, would move in for the kill. It was risky, but it kept German armor from overwhelming U.S. infantry. The truth was simple. The half-track tank destroyer was never ideal, but it was available, quick to build, and much better than sending soldiers into battle with just rifles and hope. By late 1944, both sides were replacing these hybrids with fully armored vehicles made for frontline combat. But for about 2 critical years, half-tracks with big guns filled a dangerous gap on the battlefield. And if you strip away the firepower and tactics, the core mission of the half-track becomes clear: getting soldiers to fight alive and ready to fight. Sounds easy until you look at the engineering. Building a good armored personnel carrier, APC, means juggling 3 things that constantly fight each other: protection, space, and mobility. Add too much armor, the vehicle gets too heavy and slows down. Carry more troops, now there's no room for gear or ammo. Make it faster, then it's too lightly armored to protect anyone inside. The M3 half-track's armor setup shows exactly how those trade-offs were made. The front plate was 12.7 millimeters of steel, angled at 30 degrees. That angle gave it the same protective strength as about 15 millimeters of vertical armor, enough to stop standard German rifle rounds at 100 meters, and even .30 caliber machine gun fire at longer ranges. The side armor was only 6.35 millimeters thick, just enough to stop pistol rounds and shrapnel. Why so thin? Because every extra millimeter of steel added hundreds of pounds to the vehicle's weight. Engineers calculated that 6.35 millimeters was the thinnest armor that still gave soldiers a reasonable chance of surviving close-range threats without making the vehicle too heavy to move over soft ground. The inside was all about function. The driver and vehicle commanders sat up front, each with their own seat and armored door. Behind them was a cargo area about 6.5 feet wide and 10 feet long, with bench seats along both sides. 10 soldiers sat facing inward, knees almost touching, with rifles held upright or across their laps. There was a reason for this tight layout: to keep everyone below the side armor. If a soldier stood up, they were exposed from the chest up, vulnerable to gunfire, explosions, or anything else flying their way. Units with real combat experience knew to stay seated until the very last moment before jumping out. The open top was always a hot topic, both during the war and long after. Why not just put a roof on it? 3 reasons: weight, visibility, and escape. A steel roof strong enough to block shells or gunfire would add at least 800 pounds. Too much for suspension. It would also block the crew's view and make it harder to get out in an emergency. One key reason the M3 half-track stayed open-topped: visibility and survival. Squad leaders needed to see what was happening around them, especially in combat zones. Fully enclosing the vehicle would have meant driving blind into ambushes. And if the vehicle hit a mine or took a direct hit, the open top gave soldiers a way to bail out fast. No crawling through narrow doors while the vehicle burned. But the biggest impact of the half-track wasn't just mechanical, it was tactical. The real breakthrough came with the idea of mechanized infantry. Before 1940, troops either walked or rode in unarmored trucks. By the time they reached the fight, they were tired or already taking fire. The half-track changed all that. Now, infantry could keep up with tanks, arrive with their gear, and be ready to fight the moment they jumped out. At the Battle of El Alamein in October 1942, British and Commonwealth forces used American-made M3S to follow tank breakthroughs. They hit the gaps in German lines before defenders could regroup. The result? Troops arrived fresh, fully equipped, and able to grab key objectives, something tanks couldn't do alone. The idea got a tougher test during D-Day in Normandy on June 6, 1944. American armored divisions used M3 half-tracks to move troops inland through the dense hedgerows, terrain that made tanks vulnerable. The playbook was simple. Half-tracks moved behind Sherman tanks, keeping a distance of 50 to 100 yards. When enemy fire started, the tanks returned fire while the infantry dismounted from the half-tracks, using the vehicle's sides for cover. From first contact to boots on the ground took maybe 15 seconds. German reports from Normandy noted how fast U.S. units could respond to enemy fire. Compared to German infantry, who had to dismount far away and run into position, U.S. mechanized troops were faster, better protected, and often struck first. By the numbers, a standard American armored infantry battalion in 1944 had 3 rifle companies. Each company had 3 platoons, and each platoon had 4 squads. That meant 36 squads total, which needed 36 half-tracks, plus more for supporting command. In total, about 50 half-tracks per battalion. These weren't just troop transports. Each half-track carried .50 caliber machine guns, mortars, ammo, radios, and even medical gear. They turned infantry into fast, mobile fighting units and helped shift warfare from slow marches to rapid strikes. By 1945, the question wasn't if infantry should be mechanized. It was how to build better vehicles for the job. But when you took these Cleveland-built machines and dropped them into a Russian winter or a Pacific jungle, things started to break. Fast. Real battlefield conditions challenged every assumption behind the original design. The Eastern Front was especially brutal. In the winter of 1941-42, as Germany pushed toward Moscow, their Sd.Kfz, 251s began failing in huge numbers. The smooth-riding interleaved wheels that worked so well in summer became a nightmare when mud froze between them. Crews tried everything. Lighting fires under the wheels, pouring fuel, and setting on fire, even using small explosives to knock the ice loose. None of it worked well. Eventually, German mechanics began welding steel plates over the gaps to block ice buildup. It hurt performance, but it kept the wheels moving. By late 1942, new production models had wider wheel spacing and simplified suspension, built specifically for the Eastern Front. Meanwhile, the U.S. sent M2 and M3 half-tracks to the Soviet Union through the Lend-Lease program, about 1,100 units between 1942 and 1945. Soviet mechanics immediately started modifying them for the extreme cold. The biggest problem? Cold starts. In sub-zero temperatures, the Hercules engine's carburetor would freeze up. So the Soviets added block heaters, insulated the fuel lines, and modified the carburetors with different jets to handle thickened winter fuel. They also added wooden enclosures over the troop area. These makeshift roofs helped protect soldiers from wind chill during long movements across frozen terrain. Deep snow created another problem. Standard rubber block tracks packed with snow, which then froze solid, killing traction. Both German and Soviet crews experimented with grousers, metal cleats bolted to the tracks to grip ice and snow, kind of like crampons for tanks. The Germans developed a full winter kit, with special track extensions that increased surface area by 40%, that reduced ground pressure and helped vehicles move through snow that would stop wheeled trucks cold. Installing those kits was tough, especially in freezing weather. But units that skipped the process often ended up stuck and helpless within days of a winter offensive. In the Pacific, the challenges were the exact opposite: extreme heat and humidity. Electronics shorted out, metal rusted fast, and vehicle interiors turned into ovens that could cause heat exhaustion in minutes. Starting in 1943, U.S. forces in New Guinea had to get creative. The terrain, dense jungle, swamps, narrow trails, made half-tracks seem like the wrong tool for the job. But engineers improvised. Some M3s had their front wheels removed entirely, and the tracks were extended forward, creating fully tracked vehicles. These had lower ground pressure and could crawl through swamps more effectively. Some of the field-modified half-tracks looked downright strange, but they worked. They could crawl through mud that stopped almost every other vehicle. During the Philippines campaign in 1944-45, Japanese forces came across American half-tracks and weren't quite sure what to make of them. Japanese doctrine emphasized light tanks and truck-based infantry, and to them, half-tracks seemed overly complex and too hard to maintain. And, in a way, they had a point, especially in tropical climates. In jungle conditions, both American and German half-tracks required constant upkeep. Humidity corroded wiring. Mud got into every moving part, and leaves, bugs, and debris clogged up the cooling systems. Crews had to do twice-a-day maintenance, and critical components often needed rebuilding every few weeks just to keep going. Captured half-tracks told interesting stories. The Soviets captured hundreds of German Sd.Kfz, 251s during their 1943-44 offensives, and put them to use, despite shortages of compatible parts and ammunition. Soviet mechanics often welded on extra armor, using scrap from destroyed vehicles, making them heavier and slower but better protected. Some of these reused Hanemags were turned into makeshift fire support vehicles, fitted with recoilless rifles, rocket rails, or even flamethrowers. It wasn't pretty, but Soviet doctrine always favored firepower over precision engineering. Desert warfare brought a new set of issues. In North Africa, sand tore through engines and bearings quickly. British forces using U.S.-built M3s during the Western Desert Campaign added huge air filters, some up to 3 feet tall, to keep sand out of the engine. They also swapped out standard tracks for desert-style ones, with wider blocks to help the vehicles float on soft sand. And because water was always a concern, these half-tracks often pulled trailers loaded entirely with water cans for the crew and the engines. All these changes pointed to one thing. The half-track wasn't a single vehicle. It was a platform. Dozens of versions were built, customized for different environments, each solving a unique challenge that the original factory design couldn't handle. By 1946, thousands of half-tracks were sitting in storage, from Fort Knox to Frankfurt. And with the war over, military planners had to ask the tough question, what now? The brutal truth in peacetime was clear. The half-track was a compromise. It wasn't a truck. It wasn't a tank. And in the post-war world, that in-between approach no longer fit the battlefield. The Korean War, 1950 to 1953, was supposed to give the half-track a second chance. The U.S. brought M3s to Korea, expecting them to perform like they had in Europe. But it didn't go as planned. The rough, mountainous terrain tore up suspensions and transmissions that were never designed for it. The rubber track blocks, which worked well enough in France, broke apart quickly on Korean rock, sometimes after just 400 meters. Maintenance became a nightmare. Each M3 needed around 40 man-hours of work every week, compared to about 10 hours for a regular truck. Some commanders just left them in the motor pool and asked for more trucks instead. But the real issue was how warfare had changed. In Korea, battles were fought at longer ranges, 600 to 800 yards, not close up like in Normandy. The M3's thin 6.35 millimeter side armor, which barely protected against rifles in 1944, was completely useless against the new weapons North Korean and Chinese troops had. The Soviets applied PPSH-41 submachine gun could punch through the M3's sides from 200 yards. Heavy machine guns shredded them. It didn't take long for commanders to realize using half-tracks near the front just meant getting your troops killed. Meanwhile, engineers were working on something new. By 1956, the M113 armored personnel carrier was taking shape. It was everything the half-track wasn't. Fully tracked, made with aluminum armor, which gave similar protection at half the weight. Amphibious, designed from the ground up as a troop carrier, not a truck with tracks. The M113 could swim, survive mine blasts, and presented a smaller target thanks to its low profile. First units came off the line in 1960, and by 1963, it was clear this was the future. The engineering mindset had completely shifted. The half-track was built with 1930s logic. Take what works, mix and match, and hope it holds up. The M113 was built with systems engineering, where every part was designed to serve a clear mission. Its Detroit diesel 6V53 engine made 215 horsepower, nearly 50% more than the old Hercules engine, and it ran on diesel, which was safer and more efficient. It used torsion bar suspension, which gave a smoother ride and required far less maintenance than the vertical springs used on half-tracks. Then there was the money. By the early 1960s, keeping half-tracks running was more expensive per mile than just buying new M113s. Parts were rare, since production ended in 1945. Mechanics who understood white motor transmissions were retiring. Meanwhile, M113 production lines were modern, and cost per vehicle dropped below $40,000, a bargain compared to keeping old machines running. International militaries reached the same conclusion. Israel bought hundreds of U.S. half-tracks in the 1950s and used them in the Six-Day War, 1967. But by the 1970s, they were phasing them out for newer armor vehicles. The Soviet Union ditched half-tracks entirely after World War II, jumping straight to fully tracked carriers like the BTR-50. France held on to half-tracks the longest, using them into the 1970s in colonial wars, but mostly because they couldn't afford anything newer. In the end, the half-track wasn't killed by failure. It was killed by progress. Warfare had moved on. Armies needed specialized vehicles, not middle-ground compromises. The M113 and its successors could float, survive artillery, carry heavy weapons, and most importantly, keep soldiers alive in a world of automatic rifles and nonstop firepower. By 1970, nearly every military had made the same choice. Pick tracks or wheels. Don't mix both. The last American half-tracks were retired around 1964, after more than 2 decades of service. Some were repurposed as support or recovery vehicles, but the days of using them as frontline personnel carriers were over. Today, a few still survive, in museums or private collections. Mechanical fossils, reminders of a time when engineers believed they could design one vehicle that did it all. They couldn't. But for one crucial decade, in a world that desperately needed mobile infantry fast, the half-track's flawed but clever design was exactly what was needed. For all its flaws, compromises, and short lifespan, the half-track carved out a place in military history that can't be ignored. It wasn't perfect. It wasn't elegant. It wasn't even particularly comfortable. But in the critical years of global conflict, when everything was on the line and time was running out, the half-track was the right machine at the right moment. It filled a desperate gap between what armies had and what they truly needed, a fast, mobile vehicle that could bring troops to the fight, offer some protection, and get them out again when things went wrong. It wasn't a tank. It wasn't a truck. It was something in between. And in the chaos of World War II, that was good enough to change everything. What made the half-track so revolutionary wasn't just its mechanics. It was a doctrine it helped create. Before the half-track, infantry moved at the speed of marching boots or slow-moving, vulnerable trucks. After the half-track, the entire concept of mechanized infantry changed. Troops could keep up with tanks, move as part of fast-moving armor columns, and arrive at the front lines ready to fight. It shifted the rhythm of battle. Engagements no longer had to pause while foot soldiers caught up. Armies could push forward faster, exploit breakthroughs quicker, and hold ground more effectively. In an era when speed, coordination, and mobility were becoming as important as firepower, the half-track played a pivotal role in reshaping the battlefield. The M3 and its German counterpart, the Sd.Kfz 251, became the most widely used examples. But these were never just vehicles. They were platforms. They carried machine guns, mortars, radios, stretchers, command staff, and in some cases, anti-aircraft guns or artillery. They were gun trucks, medevac units, mobile command posts, and tank destroyers all rolled into one. The half-track also became a symbol of adaptation. It was field-modified in dozens of ways to deal with the unique challenges of every theater. In Russia, it braved minus 40 degrees Celsius mornings. In New Guinea, it slogged through steamy jungles and muddy trails. In North Africa, it crossed sand dunes with dust-choked engines. Mechanics, engineers, and frontline soldiers made it work, bolting on armor, welding spare parts, adjusting engines, tracks, and cooling systems just to keep the machines rolling. That adaptability spoke volumes about the mindset of the time. War wasn't neat, clean, or predictable. It was messy and changing constantly. The half-track reflected that reality. Ugly, tough, sometimes temperamental, but always willing to go wherever the fight demanded. Of course, the very thing that made the half-track unique, its hybrid nature, was also its biggest limitation. It tried to do too many things at once, and while it did most of them well enough, it never excelled at any. It didn't have the armor to survive direct hits, the off-road power of a true tank, or the simplicity and ease of maintenance that trucks offered. By the time the Cold War began, the half-track was already becoming obsolete. Newer combat environments required vehicles that were purpose-built from the ground up. Armies needed machines that could swim, survive mine blasts, shrug off machine gun fire, and handle nuclear, biological, and chemical threats. The half-track simply wasn't built for that world. The emergence of vehicles like the M113 marked the beginning of a new era. No more hybrids. No more compromises. The M113 wasn't adapted from something else. It was designed from scratch to do one job: move troops safely and effectively. It had better protection, more power, lower maintenance, and could float across rivers. And most importantly, it was cheaper and more reliable in the long run. By the 1960s, militaries around the world were moving on. Some, like the Soviet Union, had already jumped ahead with fully tracked APCs. Others, like Israel and France, stretched the service life of surplus half-tracks as long as possible before finally letting go. It wasn't that the half-track had failed. It was simply outpaced by progress. But to measure the half-track by modern standards is to miss the point. It was never meant to be a long-term solution. It was a stopgap that ended up becoming a cornerstone of World War II mechanized warfare. It shaped tactics, doctrine, and battlefield logistics in ways that would influence armored vehicle design for decades. Even more than that, it demonstrated the power of good enough done right. In war, the best tool is the one you can build quickly, deploy widely, and keep running under the worst conditions. The half-track wasn't the best at anything, but was everywhere, doing everything at a time when that mattered most. Its short life also reflects a deeper truth about technology and warfare. Tools evolve, needs change, and yesterday's innovations become today's museum pieces. But that doesn't make them any less important. The half-track held the line when nothing else could. It helped win a world war. That's a legacy worth remembering. Today, working half-tracks are rare. Most have long since disappeared from active duty, replaced by sleeker, smarter, and more specialized machines. But in museums, private collections, and the memories of those who use them, they still stand as reminders of a unique moment in military history. They're mechanical time capsules from a period when armies were figuring things out as they went, trying new ideas, making hard compromises, and doing their best with limited resources. The half-track is what happens when engineers and soldiers meet a problem head-on and say, "We don't have the perfect tool, but we're going anyway." It's the story of how imperfect machines can still make a perfect difference when it matters most. And maybe that's the best kind of legacy any vehicle can leave behind.